Okay, in the last video you worked on multiplying like bases and you had to add your exponents. So we're going to look at a couple of more multiplication properties of exponents in this video. The first one that I want us to focus on is power to a power. So just this first one here. Power to a power when you raise two exponents here. And it looks just like this. You have a base raised to an exponent, and then that expression is raised to another exponent. So power to a power. And they're side by side, so you can kind of think of every time we've talked about when things are side by side, like a 3 and an x, that meant multiplication. So the same thing applies here. M and N are side by side, power to a power, so multiply them. So we have some examples down here. 5 is our base raised to the fourth power, which is raised to the second power. So I have this expression raised to the second power. So I have power to a power. So I simply just multiply my exponents. 4 times 2, which gives me 8. So 5 to the 8th power. Then I have m. So this is just an example with a variable. M to the third power raised to the fifth. Power to a power. So I simply take the two exponents, 3 times 5. M is raised to the 15th power now. You can look at the other two examples. They're just in fraction form. Notice that once you multiply, you just simplify your fractions as far as they will go, but leave them as the fraction. Now notice in every single one of these, we only have a single variable or a single number inside the parenthesis with the power. When we get into having multiple things inside the parenthesis, that's when it changes. The property will change. But for now, we have one variable or number. So for problem 1, I have n to the fourth power raised to the seventh power. So I've got to use my power to a power rule here. Multiply the exponents when raising a power to a power. So I have 4 and 7 are my two exponents, and I simply multiply them. And 4 times 7 is 28. So the simplified expression is n to the 28th power. So let's look at another example. This one's just dealing with fractions, but I have x to the 2/3 power raised to the 1/2. So power to a power. Same thing applies as it did in the other ones. When you have power to a power, you multiply your exponents, even if they are fractions. 2/3 times 1/2 does give you 2/6. So this is where you do have to simplify. So 2/6 simplifies to 1/3. So the simplified form of this expression is x to the 1/3 power. All right, so now I want you to try one on your own. Here's your expression, p to the fifth raised to the fourth. And here are your answer choices. So go through those answer choices, go through the last couple examples we've looked at. All right, so the simplified form of this expression, you may have been able to do this in your head, hopefully, is d. And all you have to do is just take the 5 and the 4, multiply them together. Power to a power. All right, so let's look at an example that gets a little more complicated. This is going to bring in the last couple of videos you've watched with the product, and you have the same base where you add your exponents, negative exponents, power to a power. So lots of things going on in this one expression. And that's how you're going to have to approach these expressions when they get more difficult, is looking at all the different properties that are involved. Now, this is actually following order of operations, even if it doesn't look like order of operations that you're used to. We have multiplication. We have y to the third times y to the 5/2 power raised to the -2. So we have multiplication here of like bases, and we also have power to a power because we have an exponent next to an exponent. Now, multiplication is here, exponents are here. So think about what the order of operations tells you to do. The first thing it tells you to take care of is your exponents, and then move to your multiplication. Okay, so that's exactly what we're going to do. Now I'm going to bring all of the steps up here, and you need to focus just one at a time, so follow along with me. The first thing we have to do about order of operations, you simplify powers before you multiply. So that's exactly what we're going to do here. So it's telling us over here in the think column that you must use your power to a power property. So I have 5 halves to the negative 2 power. 3 is not involved. It is not inside the parenthesis. Only the 5 over 2. So the 5 over 2 is what we multiply by negative 2. Now, once I multiply 5 over 2 by negative 2, I get negative 10 over 2. So I have y to the third times y to the negative 10 over 2 power. So I'm down to my multiplication. So now that I have multiplication of like bases, this is what we did in the last video. When you have like bases, you write that base one time, and then you add the exponents. So 3, and then this simplifies to negative 5. Negative 10 divided by 2 is negative 5. So 3 plus negative 5 gives us negative 2. So we're down to y to the negative 2 power. Now careful with multiple choice. Often that will be a choice, but we know that to completely simplify an expression from the very first video we watched with exponents, you have to eliminate that negative with your exponent. And the way you do that is using the negative exponent rule, which says you just do the reciprocal, move it to the bottom of your fraction. So we move y to the second power to the bottom over 1, and that eliminates our negative. So our simplified expression is 1 over y to the second power. So notice we had 3 different properties there. We had power to a power. That's where we had to multiply. Then we had our multiplication of like bases. So we had to add our exponents. Then we wound up with a negative exponent. So we had to follow our negative property rules, which says to move it to the bottom of the fraction if it's on the top, to simplify it completely. So take those steps and this think. This is really helpful here, the process that we have to take. And let's apply it to a problem for you. All right, so a little bit easier, maybe we don't have the fraction in there, but this is your expression. Follow order of operations. Take care of the exponent or the power to a power first. Then take care of multiplying like bases. And then if you are left with a negative exponent, you must move that negative exponent appropriately to change it to a positive exponent. Now here are your answer choices. So make sure you're following the steps from the last example on this one. All right, now your correct answer, if you need to pause the video, please do that, but your correct answer for this problem is B, 1 over x to the 22nd power. And so here's your solution. First thing they did was multiply 6 and negative 4 and got negative 24. That's your power to a power. Then you deal with multiplying like bases. So rewrite your x and then add 2 and negative 24, which gives you negative 22. And then you have a negative exponent, so you must move it to the bottom of your fraction to make it positive. All right, before we move on to our next example, the last key concept we have for this video is raising a product to a power. So this is where we're going to get into, I told you, if you have more than one thing inside the parenthesis, more than just an x or a 5 or something like that, raised to a power. This isn't power to a power, it's product to a power. Product means multiplication. So any multiplication problem in here, when it's raised to the nth power, it's sort of like distributing. Okay, the A has to be raised to the nth power, and the B has to be raised to the nth power. Okay, so if you look at this example, I have 3 times x. This product, this multiplication problem, is raised to the 4th power. So that means my 3 has to be raised to the 4th power, and my x has to also be raised to the 4th power. So it's basically like distributing that exponent to each one of the factors in that parenthesis. And then they simplify 3 to the 4th as 81. Same thing here, even with fractions. 4 times b. 4b is my product raised to this power. So 4 and b both get the fractions, and then you just simplify from there. Now, it doesn't matter. There could be 4 or 5 terms, factors in here. If it's all multiplication, they will all get this exponent. So it doesn't have to just be 2 factors. So let's take this property, product to a power, and apply it in an example.
In this problem, you will simplify a product raised to a power. Which expression represents the area of the square? Your choices are A, 10 times x cubed, B, 5 times x to the sixth power, C, 25 times x to the fifth power, and D, 25 times x to the sixth power. How do you find the area of the square? The area of a square with side length s is s squared. Square the side length of the square to find the area.
So s squared is a way to find the area of a square, and the side length is 5x to the third. So in place of s, this is just substitution. They substituted the side length in place of s in the equation.
Raise each factor in the expression to the second power.
All right, so that's the product to a power rule. If you have a product within the parenthesis, everything in there gets raised to the second power. So 5 to the first, because that's 5 to the first power there, gets raised to the second, and then the x cubed also gets raised to the second. So it's like distributing the 2 throughout.
Next, multiply the exponents of a power raised to a power.
So power to a power rule, 1 to the second power, so 5 to the first power to the second power, so 1 times 2 is 2, and then you have power to a power here, 3 times 2 is 6.
Simplify the expression.
All right, so 25 times x to the sixth power is your simplified expression for the area of that square.
The correct answer is D. Now it's your turn.
All right. So simplify this one. It's not a square type problem, an application problem like that, but you do have the product of 7 and m to the ninth raised to the third power. So each one of these factors, the 7 and the m to the ninth, has to be raised to the third power. So break it down first, then start simplifying using your power to a power rule and so forth. So here are your answer choices. There are a couple that you should be able to eliminate automatically, knowing that everything in here has to be raised to the third power. All right, your correct answer for this problem is D. And the solution to that, again, 7 gets raised to the third power, m to the ninth gets raised to the third power. 7 to the third power is 343, and when you have power to a power, you multiply those to get 27. All right, we are kind of running short on time, but I want to show you this example here because there are lots of things going on here. We have power to a power because there's only one thing in this parenthesis, in one base. Then we have product to a power because we have a 4, we have an m, and we have an n to the negative 2/3 raised to the third. So we have lots of things going on. Once you take care of those exponents, then you're going to have multiplication and simplifying and that sort of thing. So I'm going to put the solution page up here. And I just want you to go through that, read each one of the steps of what they're doing each time, and follow that along. And I want to make sure, just pause the video, make sure you've got that copied down. And I want you to see if you can apply that. Hopefully you've paused the video and copied that down. I want you to see if you can apply that to this problem. Now I know this was kind of rushed, but I just want to see what you can do. So here's your answer choices. There's your expression. You're going to have to pause the video. And the correct answer is D. So see what you can do with that problem.